In space, no one can hear you talk, laugh, or scream. At least that's how the saying goes. People can't hear anything in space due to its lack of atmosphere, which prevents sound from traveling. However, if you have the right conditions, such as the hot gas surrounding the black hole at the center of the Perseus galaxy cluster, space can actually be quite noisy. This galaxy cluster is 250 million light-years away from Earth, and researchers have captured the sound of space waves rippling through the plasma gas in Perseus. In 2003, they discovered that black holes generate acoustic signals, but it wasn't until recently that they brought these signals to the human ear. The result is a chilling and terrifying sound. Nearly a decade ago, NASA's spacecraft discovered deep canyons on Titan, one of Saturn's moons. These canyons, about a half-mile wide, resemble Earth's Grand Canyon, but they are filled with liquid hydrocarbons. This discovery marked the first time evidence of liquid-filled canyons and channels was found on Titan. Meanwhile, our solar system is full of particles and rocks orbiting the Sun, and occasionally, some of these objects change trajectory, striking planets. Most meteorites and comets originate from within our solar system, either from the asteroid belt between Jupiter and Mars or from the Kuiper belt beyond Neptune. However, 5 years ago, scientists found something unusual, a red, elongated space rock called Oumuamua. This object, likely over 3,000 feet long, was the first interstellar object observed passing through our solar system. Its origin remains a mystery, as it was traveling much faster than any known asteroid or comet from within our solar system. No one knows when or where its journey began, as the stars have since shifted positions, making it difficult to trace its origins. Our Sun, far from being a simple ball of gas, is a complex system of towering plasma fountains, magnetic fields, and massive, unusual matter. One of the most dramatic solar phenomena is the solar termination event, which occurs as the Sun moves through its natural 11-year cycle of peaks and troughs in activity. As the cycle nears its end, fewer sunspots and emissions occur due to weakened magnetic fields. When these fields collide along the Sun's equator, enormous tsunamis of plasma sweep across the solar surface, sometimes lasting for weeks. These powerful solar storms can wreak havoc on Earth's power grids. As the cycle starts anew, large sunspots begin to form along magnetic field lines. Scientists are still unsure of the exact causes of these events, but further study could help us better prepare for potential solar storms. Mars has some of the longest landslides in the solar system, with rocks that likely fell into the water billions of years ago, triggering massive tsunamis. As these waves grew larger, the rocks scraped along the Martian surface, leaving imprints on the ancient shorelines. These waves may have traveled hundreds of miles, supporting the theory that Mars once had an ocean beneath its dry, desert surface. As remarkable as Oumuamua was for being the first interstellar object, another object followed it, the comet Borisov. Borisov was first observed in 2019, and it was clear that it wasn't from our solar system due to its bright, glowing tail, which stretched over 100,000 miles. The comet likely originated in a freezing region similar to the Kuiper belt, possibly near a red dwarf star. However, Borisov was moving so fast that scientists only managed to observe it for a few weeks before it sped past Earth and out of our solar system. Finding new planets is always thrilling. In 2017, researchers discovered a super-Earth, an exoplanet that orbits a star outside of our solar system. This planet is about 3 times the mass of Earth and is located just 21 light-years away. It orbits an M-dwarf star and completes a full orbit in just 2 weeks. Although this planet is closer to its star than Mercury is to our Sun, M-dwarf stars are cooler, so it's possible that the super-Earth still contains water. Super-Earths are a category of planets larger than Earth but smaller than ice giants like Uranus and Neptune. These planets can be composed of rock, gas, or a combination of both. The planet discovered in 2017 is particularly intriguing because it might be capable of sustaining some form of life. Astronaut Leroy Chiao had a strange encounter during a spacewalk in 2005. While commanding the International Space Station, Chiao saw 5 lights in a pyramid formation flying near him. One of the lights was slightly ahead of the others. Chiao called out to his fellow crew member, who was also on a spacewalk, to ask if they could see the objects, but they didn't. Researchers later investigated satellite images and suggested that what Chow saw could have been fishing boats off the coast of South America, using bright lights to attract squid. Given the rotation of Earth and the twilight conditions, the lights might have appeared to be flying past. When a massive star dies in a supernova explosion, its core collapses to form a neutron star, the densest form of matter known to exist. In the moments after a star transforms into a neutron star, the energy it releases is equal to the total light output of all the stars in the observable universe combined. These stars are incredibly dense, with the mass of the Sun compressed into a space the size of Manhattan. If a neutron star were any denser, it would collapse into a black hole. A few years ago, scientists captured the collision of two neutron stars. The impact was so powerful that it created gravitational waves, rippling through space-time, and produced heavy elements like platinum and gold. The collision of neutron stars also generates catastrophic destruction. A wall of fire spreads around the epicenter of the collision, burning everything in its path. Waves from the explosion can cover large cities, and earthquakes of immense power cause skyscrapers to collapse. These are potential consequences of a collision with the first interstellar object in history, which passed through our solar system in 2017, Oumuamua. This mysterious object, whose nature remains unclear, whether it's an asteroid, comet, or even a spaceship, has captured the imagination of scientists. With speeds reaching 54 miles per second, Oumuamua traveled much faster than any known asteroid, capable of crossing the US in under 3 minutes. At such speeds, it could travel from Earth to the Sun in just 2 months. By comparison, our fastest rockets can only reach speeds of 17,000 miles per hour, making the same journey across the US in 9 minutes. So many scientists speculate that Oumuamua is an artificial object created by a very advanced civilization. The shape of the object supports this theory. It's long and narrow, resembling a spaceship, and it's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really a spaceship by pointing some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their technology, we would have known about it. However, there was complete silence. No radio waves were detected. But this lack of signals doesn't completely disprove the theory of an extraterrestrial civilization. To find out more, scientists decided to determine the weight of the object using light, more precisely its reflection. Different materials reflect light differently. For example, a black stone absorbs most of the light, reflecting almost nothing. Based on how much light an object reflects, scientists can estimate its weight. When they pointed their telescopes at Oumuamua, they found that it reflected colors matching iron and solid rocks. Additionally, Oumuamua was flashing. Sometimes it was bright, and then it would slowly fade before starting to shine again. This indicated that the object was spinning, but not in a smooth way. Instead, it rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads, but Oumuamua remained intact, suggesting it was made of super hard materials. Moreover, it wasn't hollow like a spaceship, but a solid body. The incredible speed of Oumuamua makes it even more mysterious. Some comets can reach similar speeds, but they have a rocket effect. Just like how a spaceship ignites fuel to push off from the ground, a comet accelerates as the sun's rays hit its surface and cause ice to evaporate, pushing the comet forward. This also creates a comet's tail, which drags behind it like a massive plume of gas. However, Oumuamua didn't have a tail and didn't show signs of this rocket effect, which means it couldn't have accelerated in the same way. Some scientists speculate that Oumuamua once had a tail but lost it. After all, it entered our solar system in 1995, and by the time we discovered it in 2017, 95% of its mass had already evaporated. Other scientists believe that Oumuamua gained its speed during its birth in another star system or nebula. It could have been the result of a dramatic collision between an exoplanet and another cosmic object. The colossal energy from the collision could have propelled this elongated shard into space. Alternatively, a supernova explosion might have blasted Oumuamua into space. When a star reaches the end of its life, it becomes a red giant before shrinking and exploding with tremendous force. This explosion can travel across light years, potentially tearing apart planets and flinging debris into the cosmos. Recently, a new theory was proposed that Oumuamua could be a giant block of nitrogen ice, similar to the nitrogen ice found on Pluto and Triton, one of Neptune's moons. This ice could have kept the object intact for 500 million years in interstellar space, and when it arrived in our solar system, it reflected 2/3 of the sun's rays, which would explain why it didn't develop a tail. However, to find out for sure, scientists plan to send a space probe to study it. The challenge is that Oumuamua is leaving our solar system at incredible speeds, much faster than any of our rockets can travel. To catch up, scientists proposed using a gravity maneuver, where the probe would fly by Jupiter to gain acceleration and then head toward the Sun to use its gravity to catapult towards Oumuamua. Another option is to launch thousands of microprobes into orbit, each equipped with a light sail. A powerful laser beam from Earth could propel these microprobes to 20% of the speed of light. However, they would need to be controlled carefully so they don't fly past the object and can enter its orbit or land on it. The goal is to catch up with Oumuamua before it leaves our solar system for good. Studying such objects could open up future possibilities for space exploration. Imagine using asteroids like Oumuamua as space taxis by landing on them and letting them carry us across space at incredible speeds without the need for fuel. Despite the potential for exploration, these objects also pose significant dangers. A collision with an asteroid the size of Oumuamua could cause massive destruction, possibly wiping out an entire state. If it hit the ocean, it could trigger waves taller than skyscrapers. Scientists are actively looking for ways to protect Earth from such catastrophic impacts. One method is ramming, sending a spacecraft to collide with the asteroid at an angle to shift its trajectory. Another approach is using controlled explosions to break the asteroid into smaller pieces or alter its path. Rocks up to 80 feet wide would burn up in Earth's atmosphere, but anything larger could cause serious damage. Some people also suggest placing rocket engines on asteroids to control their movement, which could potentially be used as a defense mechanism against other hazardous space objects. Interestingly, when astronomers started a project to create a detailed 3D map of our galaxy, they stumbled upon something unexpected. Harvard scientist Dr. Anna Banaka noticed a strange disturbance in our galaxy's stellar streams, lines of stars moving together. One stellar stream, called GD1, had a gap with ragged edges, suggesting that something massive had recently passed through it. The force of this object was so great that it dragged stars along in its wake. Shockingly, telescopes couldn't detect what caused this disturbance. One theory is that the intruder could be a stray star, but Dr. Banaka believes it would have to be much larger, at least 1,000,000 times the mass of our Sun. Some speculate that a supermassive black hole might have passed through the stellar stream, but the true cause remains a mystery.